Hi, my name is Sydney Kilgore, and today in my lesson I'm going to be going over air pressure and matter interactions with my students. The students are going to participate in an experiment, and this experiment is going to be using two 2-liter bottles that both have a balloon inside of them. One of the 2-liter bottles has holes around the bottom of it, and the other one does not. The students, however, are not going to know that one of the bottles has holes in the bottom of it and that the other one does not. And as they do the experiment, they are going to see that it's a lot harder to blow the balloon up in the bottle that does not have holes in the bottom of it than it is in the bottle that does. During the experiment, I'm going to have one student try and blow up the balloon in this bottle that has the holes in the bottom of it, and the other student is going to observe, and they're going to see that it is very easy for the student to inflate the balloon inside of this bottle. Then I'm going to have the other student try and blow up the balloon inside of this bottle that does not have holes in the bottom of it, and I'm going to have the other student observe again, and then they're going to see that it's much more difficult to blow up this balloon inside of the bottle without the holes in it than it was for the other student with the other bottle that does have holes in it. From this, they're going to be able to draw conclusions and to see the results of the experiment, that there is something else inside of the bottle or something that is not allowing the balloon to inflate as much in the one that does not have holes in it, but they're not going to know that one has holes and one does not. I'm going to tell them this though after they have completed the experiment and after they've answered a couple questions on their student data sheet to get them thinking through the process of what they've just seen and maybe some of the reasons why it might have been harder for the one student to blow up the balloon in the bottle that did not have holes than it was for them to blow it up in the one that did have holes in it. They're going to draw conclusions from this, as I said before, from the experiment, and they're going to be answering the questions on their student data sheet as they go throughout the lesson. The standard that I'm going to be addressing today is 5PS1, which is to analyze and interpret data from observations and measurements of the physical properties of matter to explain phase changes between a solid, liquid, or gas. I'm going to be specifically focusing on the first part of this standard, which is to analyze and interpret data from observations and measurements of the physical properties of matter. I'm going to specifically focus on the first part of the standard because I'm talking about air particles, which are made up of matter, and how these come from the data and how they've drawn the conclusions about that from the experiment that we've done. The objectives that I'm going to have for my students today are that the learner will understand how air pressure works and how it affects the balloon. The second one is that the learner will be able to explain that air pressure takes up space. This is also going to be my kind of guiding question for the whole lesson and experiment as a whole. I'm going to ask them this question of whether or not they think air takes up space at the beginning of the lesson, and I'm also going to ask it again at the end, and they're going to answer both of those on their student data sheet and see if their thinking changes at all from before they do the experiment to after they do the experiment. And the last objective is going to be that the learner will be able to identify the cause and effect relationship between the air pressure and the ability to blow up the balloon. Okay class, today we're going to be talking about air pressure and matter interactions. So, the first question on your student data sheet is, do you think that air takes up space? I'm going to go ahead and have you guys answer that out loud as well. So what do you guys think?
I think it does take up space.
Okay, Emma?
I think so. Maybe.
Maybe, okay. All right, so you can go ahead and answer that on your student data sheet if you haven't. And then we're going to do a quick experiment to test this thinking. So, Caitlin, I'm going to have you go ahead and try to blow up the balloon that's in the Dr. Pepper bottle, and Emma watch as she tries to blow it up.
It's
Okay.
hard.
Okay, all right. So Emma, now I'm going to have you try to blow up the one in the Sprite bottle, and Caitlin watch and see what happens. All right, so what did you guys notice about the two different bottles?
Mine lit a lot more than Caitlin's.
Mm-hmm.
Mine was a lot harder, felt like.
Okay, so why, on the student data sheet, why do you think that maybe one of them was harder to blow up than the other one was? What do you think some reasons for that might be?
Maybe you put something in here that like takes up space that we can't see, so you can't blow it up.
Anything else? Any other ideas?
I don't know.
All right. So what you said, maybe there's something else inside the bottle. What do you think could be that something else that could be inside the bottle that's taking up the space?
Maybe like more air.
More air?
Yeah.
Okay.
But there's like a liquid down here. I don't know if that has anything to do with it.
Okay, yeah, so there's a little liquid in the bottom of that one where we rinse them out. Could be it, okay. Alright, so I'm going to let you guys in on a little secret. This bottle actually has a couple holes in it around the bottom of it. And this one does not. So, now that you know that one has holes in the bottom of it and one does not, how do you think this might affect might affect why this balloon was easier to blow up than this one was?
It's the air. So this, like maybe this one, since it has holes in it, it can push the air out so that like the balloon can actually expand. But like all of the air is trapped in this one, so it can't expand. It's just like pushing against it.
Right, exactly. So this one has a lot more what we call air pressure that is built up inside of it because there are not holes in the bottom that are allowing air pressure to release and to come out, which makes it a lot harder to blow this one up because the balloon doesn't have any space to take up, so it can't blow up, it can't inflate. But this one, the air is being pushed out through the holes, the air pressure is, and so it's making the air pressure decrease in the Sprite bottle, which allows this balloon to be a lot more easy to blow up because it can expand into that now open space. So air does indeed take up space inside the bottle, and the bottle that does not have a hole in the bottom traps the air particles inside, which makes it a lot harder for it to blow up, to allow the balloon to blow up, and it creates an immense amount of air pressure that builds up inside the bottle as well. Whereas this one with the holes in the bottom allows the air particles to escape out, which allows the balloon to blow up. And also with this, when you're trying to blow up a balloon, you're forcing air particles out of your lungs and into the balloon, which bounces off the sides of the balloon and the rubber and allows it to expand. So that's kind of how that relates to trying to blow it up inside the bottle as well. So now that we have seen the experiment, you can answer the last question on your student data sheet, which is talking about whether or not you think air takes up space now after you've seen the experiment. So do you guys think yes after seeing the experiment?
Yeah, for sure.
Yes, so it kind of takes the maybe out of it. And the very last question actually on your student data sheet is a diagram. So you guys can go ahead and draw just a quick sketch of each of the bottles, the one with the holes and without the holes, and maybe draw the balloon like smaller and the one that doesn't have holes in it to show that it can't expand in that space. So today we learned that air does take up space, and you saw the effect of air pressure on the balloon, on both of the balloons. And you recognized that air is made up of particles, because the air particles inside of the bottle, but we can't see them, but we know they're there because we can see the effect that it has on the balloon when you're trying to blow it up inside the bottle. And this shows that we saw a cause and effect relationship between the hole in the bottom of the bottle and the fact that it allowed the balloon to blow more easily than the bottle that did not have holes in it. And you saw a buildup of air pressure and how this keeps the balloon from inflating. I think my Discrepant Event lesson went well today. The students seemed to respond really well to the experiment, and they enjoyed trying to blow the balloon up in both the bottles and seeing how different it was in each one. They were surprised by that and by the fact that one was a lot easier to blow up than the other one was. They did well answering the questions on their data sheet and answering questions out loud. I wish that I had required a little more student interaction, maybe with more questions where they had to draw diagrams, or just more questions where they maybe did like a table talk with each other, or talk to each other as like elbow partners. I also wish that I had added, maybe for next time, more visuals to my lesson, or maybe even a short book talking about air pressure that would expand more on the idea of it and might help them understand the concept a little better. But all in all, I think that the event went well and the students seemed to respond really well to it.